Hi guys, I hope you're okay. This is the 10th video of me recording the 2023 November question paper. It's a mathematics paper one, yeah? If this is the first video you come across, please note that there are 9 videos before this one whereby I tackle each and every question before this one. You can download the paper, answer the questions with me. If there are things you don't understand, please do write on the comment section. I'll definitely come back to you. Okay, question 10. We are told that A and B are independent, and we are given the probabilities of A and the probabilities of B, right? So they want us to find the probabilities of A and B. The probabilities of A and B will just be the products of the probabilities of A multiplied by that of B. So I'll simply have 1 over 3 multiplied by 1 over 4. By 3 over 4 rather. This will give me 1 over 4 as my probability. Okay. Secondly, they want us to find the probability that at least one event occurs. At least one event occurs, which simply means that I want to find the probability of A or B. Nah? The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. All right, together. The probability of A was given as 1 over 3. Probability of B is 3 over 4. And then the probability of A and B, we just calculated it to be negative 1 over 4, right? So this will just give me this will give me my LCD is 12. I have 4 plus 9 minus 3. So this is just 10 over 12, 5 over 6. So my probability that at least one event occurs is simply equal to 5 over 6. Okay. And then number 2, I'm told that the probability that it will snow in the Drakensberg mountain is 0.05. Okay, the probability that it will snow is 0.05. So there are two things that may occur in the Drakensberg mountain. It's either it will snow, it will either snow or it will not snow. All together, and the probability that it will snow is 5%, or you can say 0.05, right? That's 0.05. And then the probability that it will not snow, you're just going to say 1 minus 0.05. You'll simply get 0.95. Okay. And then there's further information that you are given, right? We are told that when it snows on the mountain, the probability that the minimum temperature in central South Africa will drop below 0 degrees is 72%. Okay, so the minimum temperature may drop to 0 or it may not drop to 0, right? So it may drop to 0 or it may not drop to 0. So whenever it snows, 72%, the probability is 72% that it will drop. So I'll have 0.72 and then I'll have 0.28. Are you together? Okay, same thing applies. If it does not snow on the mountain, the probability that the minimum temperature in central South Africa will drop is 35%. So it's either the temperature will drop or it will not drop, right? So the probability that it will drop, it's 35%, which is just 0.35, and then we have 0.65 here. All together. Okay, so the possible outcomes that we have, these are the possible outcomes. It's either there will be a snow and the temperature will drop, or there will be a snow but the temperature will not drop to 0 degrees. All together. And then the other possible outcome is that there will not be any snow in the Drakensberg mountain. however the temperature will drop to 0 degrees, or there will be no snow and the temperature will never drop to 0 degrees. These are the possible outcomes that we have, right? Okay, so I believe that by just taking the information, putting it on the tree diagram, we've answered the first question. We've even given the possible outcomes. Okay, and then let's find the probabilities. The probabilities. We have 0.05 times 0.05 multiplied by 0.72, and then we also have 0.05 multiplied by 0.28. Here we have 0.95 multiplied by 0.35, and then we have 0.95 multiplied by 0.65. Okay, now let's answer the question. Calculate the probability that the temperature in Central South Africa will not drop to 0 degrees in June 2024. So I'm just looking for any combination that has an outcome of a temperature not dropping. Né? So these are the only combinations that I have. All I need to do is to just say the probability that they want is equal to the probability of having a snow and the temperature not dropping, or it can happen that it will never snow, however the temperature will never drop as well. So I'll simply say 0.05 multiplied by 0.28 plus 0.95 multiplied by 0.65. So this will give me 0.05 multiplied by 0.28 plus 0.95 multiplied by 0.65. This will give me 0.6315, which can be written as a percentage because we were given our information as a percentage. But even if you left it here, there was nothing wrong there. So we can say that there is a 63.15% chance that the temperature will never drop. That's how we could have tackled question 10.2.2. Okay, and then now let's move to question 10.3. Question 10.3, we are told that there are 10 learners. There are 10 learners. Okay, I got 0.6315 as my probability there. Né? Okay, now 10.3 we have 10 learners. Né? That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there are 10 learners, and then we are 10 learners stand randomly in a line, one behind the other. In how many different ways can the 10 learners stand in the line? Okay, we have 10 learners and there are 10 positions. Are you together? So in this case, guys, yes, the answer is just 10 factorial. No? The answer is just 10 factorial. But I want to explain something so that it will be easier for me to answer question 10.3.2. If you check here, any of the learners have a chance to stand to stand as the first learner on the line. Are you together? So 1 out of 10 learners will stand here. Are you together? And then since one learner has chosen to stand here, then here we only have nine learners who have a chance to stand next to the first learner, and then we have 8 learners left. It keeps on going on and on. 4, 3, 2, 1. So to find the possibilities, we just multiply all of these together, and then this will give you 10 factorial. So the answer here is just 10 factorial ways. Are you together? And then now let's go and answer question 10.3.2. We are asked to calculate the probability that there will be 5 learners between the 2 young learners. Okay, let's say the 2 young learners are here. The first one is here, 1 2 3 4 5. Then the second one is here. Yeah? So it simply means that only 2 learners have a chance to stand there. Are you together? And then the other one will stand here. Does it make sense? That means in this place there are only 8 learners who can stand here. And why am I saying there are only 8 learners who can stand there? Because I know where the 2 young learners are located out of the 10. That means I'm only left with 8 learners. Are you together? And since I have 8 seats, I know that one of the 8 might stand here, and then the 7, one of the 7 remaining students or learners rather might stand here. 6 of the remaining, one of the 6 remaining learners might stand here. One of the 5 remaining might stand here, and then one of the 4 remaining might stand there. And then I also have 3 seats available. I know that one of the 3 learners remaining might stand there, and then one of the 2 might stand there, and then the last one will stand here. So this thing, guys, will just give me 2 multiplied by 8 factorial. Why am I saying 8 factorial? Because I have 8 times 7 times 5 times 6 times 4 times 3 times 2 times 1. Are you together? But that will happen only if the first youngest learner is standing here, and then the other one is there. But there can be changes, guys. There can be changes such that the youngest learner will now stand here, and then the other one will stand here. Are you together? Let me write this thing over there. Remember that the first setup gave me 2 multiplied by 8 factorial. Are you together? The same thing applies. I know that one of the 2 learners will stand here. Are you together? And then the other one will stand here. I'm talking about the young learners. So that means the remaining 8 learners, one of them can be here. For the remaining 7, one of them can be here. Remaining 6, one of them can be here. It goes on and on, guys. Are you together? The possibilities are still the same. Yes, I have a 2 here, but I still have 8 times 7 times 6, 5, 4, 3, 2, and 1. So I still have a 2 multiplied by 8 factorial. Are you together? So this thing will never change, guys. However, this thing can only happen in only 4 occasions. Why am I saying that? I'm saying that because the young learners can stand in this position, right? And that thing will give us and that setup will give us this guy, né? Or secondly, they can stand in these locations. This setup will also give us this thing, né? And then thirdly, they can stand here, the 2 young learners. This will give us another 2 times 8 factorial. Are you together? And then lastly, the young learners can stand here. This will give us another 2 multiplied by 8 factorial. So therefore, for our probability, remember that probability is always equal to the number of desired outcomes, let's say element in A, all over sample space. Are you together? So the desired outcomes, we are just adding these things 4 times. It's the same thing that we keep on adding 4 times. So that's why I'll just say 4 multiplied by 2 multiplied by 8 factorial all over my sample space. My sample space, guys, is whenever you are given a question in counting principle, most of the times the first question that they ask you is always your sample space. So I'll just say divide by 10 factorial. So I'll just have 4 multiplied by 2 multiplied by 8 factorial divided by 10 factorial. This will give me 4 over 45, which can be written as 0.088, or let me just say 0.089, just to round it off. Okay, that's how, guys. That's how you could have answered the last question, guys. I'm sorry for the delay. I was just tired yesterday, but just don't forget to subscribe, guys. Share, like, comment if there are things that you don't understand. Please, guys, your engagement will help us grow the channel, and maybe we'll reach a lot of learners just before they write their final exam. Bye.